Alright guys, page 173 of your student journal, section 6.4, solving exponential equations. Solving an exponential equation graphically. This is going to be the easiest part actually. So use a graphing calculator to solve each equation. I'm going to use Desmos. 2 to the x equals half. So what we have here is it's asking us for an x, and really when it equals half, this is just our y. So it's giving us y and asking us for x. So I will go here, and we'll go through all these four with you. Actually, I should probably, or the 5, I should probably add that one as well. I will actually. But let's look at this first. 2 to the x, so that's the green line. This is the green line. 2 to the x equals 1/2. I'm going to go where y equals half. If y is equal to 1 right here, then half is about that point, at which point you just click and look. Oh, on the green, when y is 1/2, which is 0.5, x is equal to -1. So that's how you solve it graphically. Literally that simple. You go to the y value and you identify x. So I can get rid of this one now. 2 to the x plus 1, which is the blue line, equals 0. So where is 0? Will it ever equal 0? Never. It will never equal 0. Like y is never equal to 0 in this graph. So you could say there is no solution. No solution. It never hits 0. It gets close. What do I mean by that? If we go here, it just gets smaller. So we have 0.2, 0.1, 0.08, 0.0654, 3, 2, 1, and it just gets smaller and smaller. But it never, even if we zoom out, it never gets to 0. I will keep zooming out. It just never gets to 0. It just gets smaller and smaller and smaller. Let's go here. It says 0, but mathematically it is not 0. It's just a really small number. So yeah, that does not check out. Or it will not have a solution. 2 to the x equals 1. So, oh, I didn't plug that in. So let's just say 2 to the x and see where that equals 1. And if we look on this blue line, oh, 0. When 0, when x is 0, x equals 0. 3 to the x equals 9, which is the orange line. Where does it equal 9? 9 is all the way up here, actually. 9, if this is 8, 9 is like in the middle. It seems to be, let's see, 2, x equals 2. Again, I'm just doing all this by graph. 4 to the 2x. I'm going to add that one actually. 4 to the 2x. We'll look at that one last. Purple, 3 to the x minus 1 equals 0. Again, an exponential function same thing. It cannot equal, it will never equal 0. I don't know why they would give that to you. How annoying. 4 to the 2x equals 1/16. So let's figure out what this is as a decimal first. 1 divided by 16. So we're looking for 0.0625. 0.0625. Where is that? Here. And I can actually erase this one. 0.0625. If this is 0.5, this is 0.06, might be around here. 625 here-ish. So you'd say x equals about negative 0.17. Yeah, negative 0.17. About. So I'll actually, negative 0.17, just an estimate. So that's how you use graphing to figure out that. It gives you a y, go find the x. 2 powers at the same positive base where b is not equal to 1, because 1 times itself any number of times will always be equal 1, are equal if and only if their exponents are equal. So if you look at this, they give you a base 2, x is equal to 5. Bye, Dad! Then x equals 5 if for them to be equal, then x has to be 5. So again, b has to be greater than 1 or greater than 0 and not equal to 1. Then b to the x equals b to the y if and only if x equals y. This only works if the base, though, is the same. They need two powers of the same positive. They even italicize it to say, oh, this is important. This is important. This is important. So 3 to the 4x equals 12. So here you would just say the bases are already the same. So now you have to make sure the exponents are equal. 4x equals 12. Divide both sides by 4. X equals 3. And wouldn't you know it, 3 times 4, or 2 to the 4 times 3, is equal to 3 to the 12. 4 times 3 is equal to 12. That makes sense. Here again, the bases are already the same. Here, the bases are already the same. Oops, 4x minus 5. Okay, the bases are the same, you just set them equal. They just have to be equal. Here, the bases are not the same. So I had to figure out, 1024 is equal to 4 to the what power? So really, I'm just going to go here and say 4 times 4. 4 times 4. 16, 4 times 4 times 4 times 4 times 4. Now, how many 4s is that? That's 1, 2, 3, 4, 5. Okay, so I could say 4 2x plus 11. 4 to the 2x plus 11 equals 4 to the, 5th power, because there's 5 4s. 1, 2, 3, 4, 5 to make it 1024. So now, for this problem, I will say 2x plus 11 equals 5. I'm going to do the same thing here, except with 8. I'm going to see how many 8s I have to multiply to get 512. So 8 times 8, that doesn't work, times 8. 3 times. So I'll say equals 8 to the 3rd. Then I will say 3 minus 2x equals 3. Okay. Let's go over, let's see here. And you just solve it. 3 minus 2 plus 0. Wait, this one's gonna act a little funny. What the heck? 3 minus 2x equals 8 to the 3rd. 3 minus 2x equals 3. If I subtract 3, it's 0. Oh, okay, that makes sense. That makes sense. I was just checking my answer. Okay, again. Let's see, 4 to 256. So that's 4 to the 4th. And it actually gets more, you would say 7 minus x equals 4. And we're going to get, let's see, 49, is it 40, does 49 going to work? 49 times 49. No, it does not work. Ugh, what a pain in the butt. So this is actually 7 squared to the x minus 2 equals 343. 7 times 7 times 7. So 7 cubed. And if you're not starting on exponent rules, which I don't expect you to be because we haven't even gone over this yet in class, but whatever. Just for the sake of showing you, we could actually multiply these exponents. So 7 to the 2x minus 4 equals 7 to the 3rd power. Then you would add by 4, or you would say 2x minus 4 equals 3. Here we have 6 squared, because that's what 36 is. to the 6x minus 1 equals 6 to the 5x. So again, we're going to multiply here. 12x minus 2 equals 5x. And you're going to get fractions for answers, and that's totally okay. Let's see here. Nine. No, this is 9 squared to the 3x, which is 3x, which is 9 to the 6x. So you say x minus 4 equals 6x. And these ones will be base 8. And I'm actually just going to leave this here. And hopefully you guys will attempt it yourselves. I'm not going to work it out all the way. Okay, bloobity blah blah. Let's see, 13. 1/7 x to this equals 2401. Oh boy, jeez. So this is actually, you could graph it also. Oh, but it tells you to, it only tells you to that here. Okay, so forget it. Let's see. 1/7 to the x equals, this is actually 7 to the negative 1. So this is 7 to the negative x equals 7 times how many? 7 to the 4th. So negative x equals 4 divided by negative 1. X equals positive 4. Sorry, x equals negative 4. So, oops. 1, no. 1 divided by 7. Oops. To the negative 4. Boom. Okay, this is, geez, this is really rough. I don't know why they give you these hard problems. This is 2 to the negative, I believe, 8th? Or sorry. Yeah, no. So 2 to the negative 9th equals 2 to the 3x minus 1. This is 5 squared. 2 minus 2x. You're going to use the same techniques as like 10, 11, 12 to solve to get this. Equals, let's see, 5 to the, what is 625? 5, 5, 5, oh, 4. 5 to the negative 4 times, or to the x plus 1. Again, you just have to distribute this. Wow, these are, I would say 13 through 15 are pretty tough. If you can ace those, like, you really, really, really understand it. And good for you if you do. Again, you're just setting them equal to each other. Once the base is the same, so that's important. Use a graphing calculator to solve the equation. Okay, I think I'm just going to do one of these for you just to remind you what it looks like. So 3 to the x plus 3. Okay, graphing. I want graphing. 3 to the x plus 3. And I'm looking for 9, when y equals 9. So let's see here. Wait, where is it? Let's do another 3 to the x plus 3. What's wrong? Why isn't graphing? Oh, it's too, sorry, I'm not zoomed out enough. There it is. Okay, I'm looking for 9, which is just under 10. Is it there? Oh, let's see. Okay, let's see, let's zoom in a little bit. -1, 9. So So say x equals -1. Okay, so all these you're essentially just typing into your graphing calculator. This one's kind of rough, so before we do this, let's add 2x, add 2x. You want all the x's to be on one side. -2. I'll actually do this one for you because this one also is very rough. Jeez. Negative to the negative x plus 1 plus 2x. So I'll say 2 to the negative x, or sorry, -2 to the negative x plus 1. Jeez. -2 to the negative x plus 1. Don't forget your parentheses. Plus 2x. Plus 2x. And I'm looking for a y value of -2. So I gotta zoom out. I gotta go to -2. Oh, well, that's convenient. It's just 0. Nice. That's it, guys. So make sure x is on the same side. Oh gosh, how are you gonna do this? You would just subtract this. So 2 to the x plus 2 minus 5x plus 2 equals 0. Wow, once again, so 20 you will solve exactly the same way. 21 you will solve like you solve this. You add half x to both sides. And you look for when y is equal to -3. For this one I subtracted it, so you'll subtract that as well. 2 to the x plus 2 minus 5 to the, oh, is it the same thing? X plus 2, x plus 2, x plus 2. And we're looking for when y is equal to 0. Boom, at -2. Holy cannoli. Alright, guys. Wow, yeah, very, very rough, but not impossible. Just make sure your graphing calculator is your best friend. It's a tool, but it's only as good as the person using it. So make sure you make good use of your calculator. Sorry, I realized I didn't instruct you on how to use this. So when I do a power, you could go like this, and as a shortcut, so like 2 to the parentheses. You could use that. If you're using your keyboard to get exponents, you use this, which is Shift 6, or at least it is on my keyboard. It's just a little caret that gives you a power, or exponent rather. Okay, so whew, is that it? There's a word problem here. This refers to, what is this, one section or two sections ago? So your principal will be 1,000. Your final amount will be 1,500 times 1 plus interest rate divided by 1. Compounded yearly, that just means once a year, so it's just 1 times t. So you guys will plug this into your graphing calculator. 1,000 times 1.05. In your graphing calculator, you could say to the x, and you'll see, sorry, leave that alone. You'll see when y equals to 1,500. So again, just pop it into Desmos. Look for when y equals 1,500. You'll have to zoom out all the way to see 1,500, which again, you just keep zooming out until you see 1,000 there. You'll have to look for it somewhere here. But otherwise, that's it, guys. Oof, I know it was not a simple section, so you're probably going to have to look at this, watch this video again. Make sure your calculator is your best friend. If you don't understand something, make sure you ask your teacher or let me know.